The Sun is currently settling down for a period of low activity as it flits into a solar minimum that should last around 11 years. This usually means that there is less sunspot activity from the sphere of swirling hot plasma, but in an ever flamboyant manner only befitting of our closest star, the Sun decided to go out with some style. In September there was a massive increase in activity as one particular spot on the surface of the star erupted, sending over 30 flares out into space. The particularly energetic patch even managed to produce the largest solar flare seen in 12 years. During all this turbulence, a whole host of organizations were training their kit at the active region, known as Arkansas 2673, and managed to snap some pretty incredible images of what was occurring. Different agencies, from NASA to NOAA, JAXA to ESA, studied these coronal mass ejections using different wavelengths of light, allowing researchers to explore the flares from multiple different perspectives. With multiple views of solar activity, scientists can better track the evolution and propagation of solar eruptions, with the goal of improving our understanding of space weather, wrote Lina Tran from NASA's Goddard Space Flight Center. To better understand the fundamental processes that drive these events and ultimately improve space weather forecasts, many observatories watch the Sun around the clock in dozens of different wavelengths of light, Tran continued. Each can reveal unique structures and dynamics in the Sun's surface and lower atmosphere, giving researchers an integrated picture of the conditions driving space weather. So sit back, scroll down, and take a look at some of the best fireworks of the solar system. This particular outburst was caught by NOAA's Geostationary Operational Environmental Satellite 16, or more simply GOES-16. This looks at multiple wavelengths of light, focusing mainly on the Sun's upper atmosphere. This GIF shows the biggest solar flare since 2005, known as an X9.3 flare. The activity is measured in an exponential manner, so X2 is twice as powerful as an X1 flare, and an X3 is 3 times as intense. For example, this image, taken using NASA's Solar Dynamics Observatory, shows that X9.3 flare, as well as a few X2.2 outbursts, in a wavelength of extreme ultraviolet light. Using an X-ray telescope on the site of JAXA NASA's Hinode spacecraft, researchers captured this X8.2 flare as it erupted from the Sun. That same flare, which occurred on September 10, was also associated with another effect seen in the lower atmosphere of the Sun, known as supra-Arcade downflows. Captured here using NASA's Interface Region Imaging Spectrometer, it shows solar material appearing to swim down towards the Sun's surface like tadpoles. Thanks for your watching. Please share this video and don't forget to subscribe.